Okay, now we're on to the next lesson. This one is on graphing reciprocal functions. So we've worked with reciprocals in the past when we've done the index notation, and actually in the last function unit we did, it was called the inverse. It was like the reciprocal. So when we look at this, I've already kind of written things up here, but what we're looking for is it's going to be a reciprocal graph if you see either a value like this, where you have its x is in the denominator, or they can also write it so you have x to the negative 1. So we know that these are the same thing. So when we have a negative exponent, it just means the reciprocal. It goes into the denominator. So we'll remember that either of these are the same thing. So when you see these, and if they show you it like this, then we'll have to simplify it so you know when you plug it in, when we do the tables like we've done in the past for the last two, you'll know how to plug it in correctly. So anytime you see either 1 over x or x to the negative 1, that is going to be a reciprocal function. And again, for this one, the general term is less complicated than what we've had in the past with the ax cubed plus bx squared plus cx plus d. This one, the general form is just y equals a over x. So that's going to be the general form in which you will see it. And they will look a little bit different. Because we have an x in the denominator, x cannot be, like we said for the other ones, it can't be 0. You can't have 0 in the denominator. So if you were thinking of a normal fraction, if we said there is 0 pizzas and we want to divide it into 5 pieces, that's impossible. It can't happen. We can't ever have 0 in the denominator. So because of that, when we do the tables, we will not include 0 in the tables. On the exam, if you include 0 or if you connect the line through 0, it will not be correct. It cannot be a value. Now, so what happens because we can't have 0? Well, we have what these things look like. They're called asymptotes. So what that means is they go all the way as close as possible to a value, but they won't actually get to 0. So if we think about this a second, if we have a fraction and we have x, so in the denominator we're saying y equals, we'll just pick 1. If x is a big value, big number, whatever, then y is going to be small. So if you have a big value for x, y is going to be very small. It can't ever be 0 because we can't ever have a 0 in the denominator, but it's going to get as close as possible to 0 but never touch. That's what an asymptote is. It gets really close, but it tends towards it, but it won't ever get to it. The same way, if we have a small value, small number for x, then we have y is going to be a big value. So if you think about this with actual numbers in here, if we have a big number, 1 over, let's say, 100, 1/100th is a small number, 100 is a big number. If we said 1 over, let's say, a very small number, let's say 2, 1/2 is obviously a bigger value, so y will be a big value. So as you can see, it'll be obvious. Again, we're going to have a table, and I'll show you what this looks like with a sample equation to look at an example. So again, we will have asymptotes. These lines will not connect. So again, do not connect them. If we have a positive value for a, your lines will be on the positive here, the positive quadrant 1, and then it will be diagonal to it in quadrant 3. So again, just to refresh your memory, we go this way, 1, 2, 3, 4, as far as the quadrant number. So if you have a positive value, it's going to be 1 and 3. If y equals negative a over x, it will be in quadrant 2 and 4. So again, if you think about the a is positive, then it's going to begin in the positive quadrant. If it's negative, it will begin in the negative quadrant. And then it's always just diagonal from it for the other one. You'll see because the values will lend itself that way and the coordinates will be in those spaces. But just so you have an idea of what it's going to look like. If you have something, if you have a over x, you can have it also be plus b. So in that instance, it's going to, whatever this plus or minus, it's plus, so everything's kind of raised above the x-axis. If it was a minus b, then everything would be below the x-axis. And you can see the asymptote now is not around 0, because b is 0 because it's non-existent in those equations. It's b, whatever that value is. Let's say that's a 2. Then the asymptotes will be at 2. It will tend towards 2, but will never get to 2. So let's put some actual equations to this, and you can see what this is going to look like. So if we have the equation, let me flip the page here. So let's use the equation that they've given you in the book. We have y equals 2 minus 3 over x. And they're telling us to use x values -3 to +3. We want to do the same thing we've been doing. We have the x values on the top, and we begin here. So we have -3, -2, -1. Okay, at this point we can't get to 0, so we want to get close. So the book shows you they do -0.5 and -0.2. So we can do the same, -0.5. We'll just stick with -0.5 for the moment. And then we can't do 0, so we're going to do, let's put a -0.5 just so you know it's more clearly. Then we have 0.5. Then we can do 1, 2, and we'll kind of land on a space here, 3. So when we're looking at this, it's the same idea. You just have to be very careful not to include 0. There is a big divide right here, so make sure that you see it and you don't actually combine those coordinates. That will not be correct. Okay, and then the next thing we do is we separate out the expressions on the left column here beneath the x. So firstly we have the 2, then we have a -3 over x, and then that'll give us the y coordinate. So let's go ahead and plug in the values and see what we come up with. This again is nice. It's just 2, 2, 2, 2, 2, 2, 2, 2, because we don't actually have to do anything to the x value. In this case, we're just substituting it in again. So this case we have -3. We have -3, which is the same thing as a +1. So we have 2 and 1 give you a y value of 3. So this coordinate will be -3, 3. All right, let's do the same thing with this one. -2, so we have -3 over -2. That's the same, the negatives cancel out because there's an even number of them. So we have the same thing as 1.5, or 1.5. Okay, we have 2 and 1.5 give you 3.5. Okay, now we have -1. -3 over -1 gives us a +3. 3 and 2 give you 5. See where we're going? This is exactly the same thing. You just need to make sure as you fill out the table that you're doing it accurately. If you have any doubt, use a calculator. Okay, we have -0.5 on this one. So if we plug this in, then we have -3 over -1/2. Now if you, again, you can do this in a calculator, but remember when we divide, we multiply by the reciprocal. So these negatives will cancel, and this is the same thing as +6. Okay, so we have 2 and 6 give you 8. All right, now we skip this line, and we go to +0.5. So the 2 again is the same, and we have 3 over 1/2, which is -6. Okay, 2 and -6 give you a -4. 1, now we have -3 over 1, which is -3, -3 and 2, a -1. Alright, if we plug in a 2, -3 halves is the same thing as -1.5. -1.5 and 2 gives us a +0.5. And then if we plug in a 3, -3 over 3 is a -1. -1 and +2 give us a +1. So again, these are going to be the coordinates. This is the x value, this is the y value. Let me just make sure everything looks the same. Okay, so if we plug in a 0.5, well, we've kind of wasted my big graph, but that's okay. So if we look at this, we're going to plug these points in now. we'll begin with this one, -3. And if you notice, you want to space out the x-axis so you can clearly see the -0.5 or the -0.2. It'll be more obvious that way. So if we go -3 and then +3. So there we go. This is our initial point. Then we have -2, 3.5. So this is 4, so we have to go 3.5, so halfway in between. Then we have -1, 5. Then we have -0.5, 8. So go up there. If we did the next point, -0.2, that would actually be here on 17. So we can go ahead and write that in even though we didn't figure that out. Okay, if we go now to +0.5, that's going to be a -4, right there. 1, -1. 2, 1/2. So 2, 1/2. And the last point is 3, 1. So here is 3, 1. Again, if we would have done the this 0.2 value that we skipped, it would have been -13. So we'll just go ahead and put that on here as well, just so you can see what it's looking like. So when we draw the lines in now, you'll have to be very careful because they're not going to connect. Again, use as smooth of a line as you can. You can see what's happening here. So this is what it should look like. You have two totally separate graphs. So when you look at it, they should never combine. When you have a reciprocal, anytime you have anything that has the x in the denominator, you cannot have points that cross the 0 point, the y-axis. Okay, so make sure that that's always the case. You will never have points that cross the y-axis. If you do, then you've made a mistake someplace in the table and you'll need to go back and fix that. So if you look in this case, they'll ask you what is the equation of the asymptotes. Basically, what is the line that it's not going past? So if you see on this one, we can see very clearly, and they'll tell you in the equation, it's going to be 2. This is the line that it's not going to go above or below. It'll stay on this line. So the equation of this line would be x equals 2. That's going to be the line of your asymptote. Alright, so that's going to be this lesson. If you are confused by anything, please go back in the book or look at this video, watch this video again. But hopefully it will become clear, and then after that we're going to look at another type of function that we'll graph.